Welcome to today's Explainer. I am so thrilled to have you here because, honestly, we are about to look at one of the most fascinating mathematical derivations in all of modern physics. If you spend any time looking into relativity, you probably know that the relativistic Doppler effect is almost always derived from the highly abstract laws of electrodynamics. But it raises a really interesting question. Is there a purely physical, beautifully mechanical way to prove it? Well, today we're going to walk through a step-by-step mechanical proof of the relativistic Doppler effect together, using absolutely nothing but the undeniable foundational laws of conservation. Let's dive in. Here's our quick roadmap for today. We'll be covering context, Newton and relativity, the physical setup, conservation of energy and momentum, the relativistic solution, classical versus relativistic, and finally, the absolute speed limit. Section 1. Context, Newton and relativity. Okay, so this entire explainer today is based directly on Chapter 16 of the book Newton and Relativity by Sester, Clemente, and Korff. Now, there is a really crucial detail you have to keep in mind about their unique approach here. The relativistic formulas we're actually going to use for this proof were derived by the authors in previous chapters without directly or indirectly using the postulate of the constancy of the speed of light and without using the Lorentz transformations. I mean, we are literally building this from the ground up purely mechanically. To put that into perspective, think back to Albert Einstein's famous fourth paper in 1905. He used the relativistic Doppler effect derived from abstract electrodynamics to support his hypothesis about mass and energy. On the left side of the screen, we have that classical 1905 foundation. But looking over to the right, this is our sandbox setup for today. Instead of purely abstract light waves, we're using a physical, completely mechanical process, electron-positron pair annihilation. It basically takes this massive cosmic concept and drops it right into a tangible mechanical arena. Section 2. The physical setup. So the core mechanism at play here is pair annihilation. If you need a quick refresher, this is simply a physical process where a particle's entire mass transforms completely into photon energy. Nothing is lost, nothing is wasted. Physical mass literally becomes light. It is one of the absolute most elegant transformations in physics, and as you'll see, it's the perfect isolated system for our proof. All right, looking at phase 2 and phase 3 of this process, let's see how this actually builds out. Over on the left, in phase 2, we have a mass, our particle, moving at a velocity v relative to us, the observer. Then we hit the transformation threshold. Boom. Annihilation. On the right, in phase 3, that mass has completely vanished, and in its exact place, two photons are emitted in exact opposite directions. One is moving forward with frequency f1, and the other is moving backward with frequency f2. The entire mass of the particle, m0, has been 100% converted into the energy of these two photons. Section 3. Conservation of energy and momentum. Okay, let's look at our first axiom, conservation of energy. Equation 16.3 here dictates that total energy is perfectly conserved before and after the annihilation. On the left side of the equal sign, we've got the relativistic total energy of the moving particle right before the event. And on the right side, we have the total energy of the two resulting photons, which is just Planck's constant h multiplied by their respective frequencies. The total energy before exactly equals the total energy after. It's a fundamental rule. Right, now let's look at axiom 2, conservation of momentum, shown here as equation 16.4. The system's directional momentum also has to be perfectly preserved. So the left side gives us the relativistic momentum of our initial moving mass. The right side calculates the net momentum of the two emitted photons. Notice that little minus sign on the right? That's simply because the right moving photon carries positive momentum, while the left moving photon carries negative momentum. So the initial momentum of the particle perfectly matches the net momentum of the photons flying apart. Section 4. The relativistic solution. This is where it gets really good. The crucial point is how these equations talk to each other. If we take the mass-energy equivalence, the fact that the rest mass, m0, equals 2 times Planck's constant times the baseline frequency divided by the speed of light squared, and substitute that right back into our energy and momentum equations, something beautiful happens. We can algebraically simplify all this math to isolate the frequencies. This yields a unified system of equations that perfectly defines the sum and the difference of the precise frequency shifts in both directions. And when we solve that system, we get this, equation 16.5. I mean, just look at the structural elegance here. The f prime represents the new frequency. Now that blue portion of the equation, that is the exact standard classical formula for the Doppler shift. But look at the green symbol tacked onto the end. The relativistic relation is mathematically identical to the classical formula.
It's just simply multiplied by gamma, the Lorentz factor. This proves that at very low speeds, where gamma is essentially just 1, the classical formula works perfectly. The classical model isn't completely wrong. It's just a limiting case that is perfectly preserved within the much broader relativistic reality.
Section 5. Classical versus relativistic.
Okay, let's visualize this to really see the difference. On our horizontal axis, we have velocity, getting closer and closer to c, the speed of light. The vertical axis is the frequency shift of an approaching light source. Now, the violet curve represents the classical physics model. Notice how it hits a hard ceiling? Under classical physics, as a light source approaches you, its frequency can only maximally double. It hits a ratio of 2 and just stops. But what happens if we look at our newly derived relativistic formula, the green curve? As the velocity approaches the speed of light, the frequency doesn't just double, it scales up dramatically, shooting up toward positive infinity. The classical model completely fails to capture that immense energy scaling near light speed.
Section 6. The absolute speed limit.
So what about the receding limit? Again, velocity is on the bottom. Now, both models, the classical violet line and the relativistic green line, absolutely agree on one major thing. You cannot exceed the speed of light, which is that red danger zone at a velocity ratio of 1.0. But look at how differently they handle it. If you plug a velocity greater than the speed of light into the classical equation, the violet line just plunges straight down into negative numbers. It yields impossible, completely impermissible negative frequency values. It is a mathematical failure. But the relativistic relation? It possesses absolute mathematical sharpness. Because of the square root denominator in the Lorentz factor, the equation becomes strictly undefined for any velocity equal to or greater than c. The math simply refuses to allow it. No impossible numbers, just a hard, elegant boundary. So, just to bring this all together, the classical model relies on a simple linear shift and tells us an approaching light source only ever doubles in frequency. Crucially, its mathematical validity totally breaks down past the speed of light, giving us nonsense negative numbers. Our mechanically derived relativistic model, on the other hand, scales properly using the Lorentz factor. It shows approaching frequencies scaling to infinity and elegantly becomes mathematically undefined at or beyond the speed of light. Essentially, the classical model is just a low-speed approximation. It entirely lacks the strict mathematical boundary constraints required by the actual laws of our universe. By looking at this very simple physical process of electron-positron annihilation, we've actually done something pretty profound today. By bypassing abstract electrodynamics entirely, we used the completely indisputable mechanics of energy and momentum conservation to provide a complete, physically grounded proof of the relativistic Doppler effect. We've harmonized the classical bounds with the relativistic limits, and through pure algebra, confirmed the absolute speed limit of light. Which leaves us with a truly fascinating thought to end on. Remember, we didn't even need to assume the speed of light with a constant to start this proof. The basic mechanical laws of energy and momentum forced that mathematical reality upon us. If pure mechanical conservation alone dictates the absolute speed limit of the entire universe, what other massive cosmic truths are hiding right there inside our most basic foundational laws of physics, just waiting to be mechanically derived? I really hope this explainer sparked your curiosity today, and I highly encourage you to keep questioning, keep learning, and keep exploring the mechanics of our reality.